Hey, welcome back. This is the Web3 Idiot. I'm back from a short break. I just got back from Okinawa, Japan. I had a lot of fun there. Nice little honeymoon, I guess we could say. Today we're tackling number 1791, Find Center of Star Graph. This is part of the daily questions on LeetCode. I'm going to start off with a pretty easy one. So there is an undirected star graph consisting of n nodes labeled from 1 to n. A star graph is a graph where there is one center node and exactly n minus 1 edges that connect the center node to every other node. You are given a 2D integer array called edges, where each edge of I is equal to u of I, so u of I and v of I. Indicates that there is an edge between nodes ui and vi. Return the center of the given star graph. Okay, interesting. So here's our star graph. We have our 2, that is the middle of our star. Out goes a 4, a 3, and a 1. So every node is connected to this number 2, this 2 node. So this 1 is connected to this 2, this 4 is connected to this 2, and this 3 is connected to this 2. So we are given the edges based on a simple array of arrays. So our first edge would be 1 to 2, that would be represented here. Our second edge would be 2 to 3, that would be here to here. And our last edge would be this 4 and 2, so this edge here between 4 and 2. So you might be wondering to yourself, this is a little complicated. How do we go about doing it? It is an easy question. So let's go ahead. Let's come over here. Let's type it out. So for example, we're given, what was it? 1, 2, a 2, a 3, maybe 2, 4, and then a 3 and a 2. So that is what we're given. So basically what we want to do is go through all of these and find the node that exists in every single edge list. So we know this 2 exists, this 2 exists here, and this 2 exists here. So because this 2 comes up 3 times and there are only 3 edges, that means we know that just based on frequency, so we have our frequency map. We could do, this is one way, so 1 occurs 1 time, 2 occurs 3 times, 4 occurs 1 time, and 3 occurs 1 time. So this 1 shows up once, this 2 shows up once, this 2 shows up a second time, 4 shows up the first time, 3 shows up the first time, the 2 shows up the third time, and we're done with our edge list. So all of them have a value of 1. They appear 1 time except for this 2, which is the center. So that is one way to go about doing this. We could also simplify it even further. We know that each edge, each node on the outside only shows up 1 time in our edge list. So if a node shows up twice, we can guarantee that that is the middle of our node. So we don't even have to check all of these. All we got to do is check these first 2 ones right here. Let me drop it down here. Why won't you paste? Can I not paste? All right. We'll just keep moving on. So we have our 1 and our 2. And then our 2 and our 4. You know what? No matter how long this is, if this is a 2, 5, this is a 2, 6, and so on, these numbers don't matter at all. Why? Because all we need to do is find the first instance in which case a duplicate shows up. So here we have our 1 and our 2, our 2 and our 4. Pretty straightforward. So one way of doing this would be just a simple if check. So, if our index, our value at index, I guess 0 and 0, so that would be this 1 here. And then we have to see if it is equal to this 2. If it is not, we check if it is equal to this 4. If it is not, that guarantees that this 2 right here would be the value we return. Because we know that the center node will appear one time in every single one of these edge lists. So this 2 will always show up. So it's a pretty straightforward way of solving it. So for example, we say if we'll do edges at 0, 0 is equal to our edges at, we'll go into our next one, 0 and 1. So all we need to do, again, that's what we're doing here. We're checking if this 1 is equal to this 2 or this 4, or edges at 0, 0 is equal to our edges at 1, and then the other element in there. If that is true, then what we do is we return edges at 0, 0. That means we've come across a match. Else, if that is not the match, it guarantees that edges at 0, 1 would be the match. So we would return that. Return edges at 0, 1. And then, yeah, that's, let's see, we are missing, do we have everything? No, we got it there. Good. Yeah, that's all you got to do. Let's run it. So, yeah, we have an O of 1 runtime and then O of 1 spacetime. So we're not storing anything. All we're doing is checking. So this is O of 1. This is O of 1. Yeah, just an O of 1 runtime, and then spacetime. We're not saving anything. So if we submit it, what do we get? We should get pretty high up. We are better than 96.98% of other individuals when it comes to our runtime. So memory, 33.64. I'm not too sure how you're able to get that down further. But, sometimes questions like these, they only look complicated, but when you find maybe a trick or two, it really simplifies it. So, yeah, that's about it. So all we do is we ignore this other unnecessary information. This part here, we don't care about this. We don't care about this stuff at all, All we do is we care about these first two, because we know that the center node will appear one time in both of these, and we're just looking for the center node. And that is how we do it. We just look for the match. So that is how you do number 1791. Pretty straightforward. Find center of star graph. Go ahead, give it a shot yourself. And if you have any questions, put them below. So this is going to be a new series called Daily Questions, where we're going to go through the daily questions of LeetCode. We're working on a few other series geared towards other company interview prep. So be on the lookout for those. And then, if you have any requests for company interview prep, put them below. I'll try to make some videos on those. And have a great day. Bye.